Welcome to Brain Vision.
In this question, we are looking at how much energy that a dam is able to convert. Right, water from a lake. So we're going to assume this is the part of the dam over here that is stopping the water from flowing. We are given that this distance from the level of the lake to the bottom of the dam is about 150 meters. We want to find what is the energy stored in the top 1 meter of water, top 1 meter height of water. And to do that, we're gonna assume that the gravitational potential energy is just mgh, where h is 150 meters, sorry. What we need is to find what is the mass and the just the mass, right? So the mass can be found by taking density multiplied by the volume. The volume in this case is taking the surface area, which is 3 times 10 to the power of 6 meters square, multiplied by 1 meter of height. Density is given to be 1000 kilograms per meter cube. And so we can find the total stored energy, taking 1000 is the mass multiplied by g 9.1 and the height, which is about 150 meters. So the energy we get is about 4.4 times 10 to the power 12 joules. Given that about 90% of the stored energy is converted to electrical energy, we want to find what is the volume of water needed to produce 1000 kilowatt hours. Well, the actual energy required is not 1000 kilowatts, but rather taking 1000 divided by 90% times a 100% efficiency. So we want to find what is the actual 100% energy that is required. And this gives us about 111 kilowatt hours. So this is the actual energy that is required. We equate this to the gravitational potential energy, mgh, as with our previous expression. So just rho times v is g times 150 meters. And to be able to do this, we need to make the assumption that the amount of height, the height of the volume that is required is sufficiently smaller than our 150 meters distance. Right, so this is the assumption. Then we're going to check whether this assumption holds subsequently, right? And so with this amount, we can find what is our V. So we will first need to convert, of course, kilowatt hours to joules. We can convert that by multiplying by 1000 to convert from kilowatts to watts. then multiplying by 3600 seconds per hour, and this will give us in terms of joules. We equate this to rho V times G times 150, and from here we can extract what is the volume of water that is required, which is 2.7 times 10 to the power of 3 meter cube. And so what is the height, right, of water that is required? What is this thickness of water? We just take V divided by the surface area, which is 3 times 10 to the power of 6. And we should get 9 times 10 to the power minus 4 meters. And this is a very small number, right? Much smaller than 150 meters, the distance, and so this assumption is a very good approximation.